we have a question that has many functions, right? H to M there, and it's a non-calc question. But we're asking which of these functions have a different derivative to most of the others. Okay, so let's just got to go through one by one and figure out what the derivative is. So first of all, let's find the derivative of let's find the derivative of h of x there. Now, given that 2 pi is a constant, it's like the number 3, if you try and find the gradient of a straight line, you're always going to get that it's 0. The ball on top doesn't want to roll either to the left or to the right, so it's got a gradient of 0. Whereas if it's positive, the ball wants to roll to the left, and if it's negative, the ball wants to roll to the right. So that makes it quite easy. Whenever there's a constant, it's just going to delete that, and then we get the 2, and put it down there, and then we get that 2 minus 1, which is just like saying 2x. Okay, cool. That's easy enough. Let's try this other one here. Let's simplify this guy because he's kind of got a lot going on there. I can see that they've got a common factor of x between everything there. So let's just split up the fraction like this. And then we can simplify it by removing everything there. And that then becomes x plus 3. So what is I of x, given that we've found the derivative of it? So there's 2 little dots there. Well, the x is really simple. That's just going to be 1. And then the 3 is the same case before. It's like trying to find the derivative of a constant. So that's going to be 0. So in this case, I prime of x is going to be equal to 1. Nice and easy here. Okay, so let's go to j of x. Let's simplify it though, because we can, and there's no point trying to work with that. So whenever we have a square root, we raise it. Okay, we raise it to the power of 1/2. And that means that this is going to be x minus by 5. So let's find the derivative of that one. And that would just be equal to 1. Same as before, right? Same as before. Okay, let's find this value of k. A little more confusing, I guess, as k is a function within a function. So hopefully we can see that it's some function here on the outside. It's like something to the power of t, like the square root of t. And then if we differentiate that, we're going to get that being equal to, right, like 1/2, and then it becoming all to the power of minus 1/2. Okay. Now t in this case we can say is equal to t in this case is equal to 3 plus x to the 4. Okay, so when we differentiate that, we times the differential on the other end here. Okay, so let's put the actual value in there. So 3 plus x to the 4. And then the differential of this one with respect to t, again, that 3 does nothing because it's a constant, but something happens with the x to the power of 4, and we get that value there. And that is equal to the value of k there. So we've got quite a lot of different things here. So far what we're seeing is that the most common, which I'm going to highlight here, is going to be that one and that one. Everything to the power of 1, or everything is just equal to 1 so far for the gradient, whereas we've got some different ones which will be equal to h and also k, which is quite complicated. Okay, so now let's get on to the next one. I'm just going to redraw it out because it's running out of space there, as you can see. So we say that L of x is equal to pi divided by 4 minus pi minus x squared. Okay, that, let's simplify it. That's a lot easier, isn't it? Now let's find the derivative of that. Oops, getting used to drawing my t's. This guy here becomes a 0 plus 2x. That's it. So that 2 comes down. And now, finally, we have the next part of the question, which is asking about m. And this is asking what is x squared on 3 minus 7. Let's simplify this. So it becomes x on 3 squared. So we just apply it to every coefficient inside of that bracket. And we can simplify that further. Now, let us find the differentiated value here. And so this one here is equal to, again, that 2 comes down, all divided by 9, and then we get a plus 0. So really, we have quite a few different types of equations here. Now, the original question was asking which of the functions have a derivative that is different to most of the others. So we've kind of got a draw here because we've got 1, 2 being equal to 1, and then also 1 and 2 being equal to 2x. So the other ones that are most different would be m, because that's 2x divided by 9. So the value of m, k, yeah, m and k are the key ones here. They're different to the rest of them. So we can write that in as part of this one here to say that m and k, and then let me do a final check just to make sure I haven't missed anything. 2x, 1, 1, k, 2x, and 2x over 9. So yeah, it's just m and k are different to the others. The next one is we've already done this. It says find the derivative of the functions where the derivative is not equal to 2x. So we can go backwards here and say that this is equal to 2x on 9. And we also have j and I also being equal to, so I equals to 1, j equals to 1, k, and you know what that is. You can have a look at the previous one there. And then I don't think we're missing any others there. That's it. So that question is just about simplifying before differentiating as often as possible. There are plenty of exam questions like this. On my website, you can find the link in the description below, and each of them have hints and fully worked solutions available, and you can just keep clicking next to find your next exam question so you can get really ready to prepare for your exam and get the highest possible marks that you can.